Hello, this video is supposed to be like a little tips and tricks for creating these data-driven tracking effects in COPS. Yeah, just some stuff I learned along the way and wanted to pass along to you. Before we start, let's take a look at the general setup. We've basically just got the test geometry crack here. It's unpacked, scaled, and then there's just some animation that it loops. And I've basically just rendered that out with some textures and then imported it back into COPS as an EXR sequence. So this is what we're working with. Alright, let's start with this setup right here. As you can see, we bring in the rendered crack output and we use the stamp point cop to stamp some markers on top. The problem with this whole setup is there's no node to rasterize points. We've got a rasterize geometry cop and a rasterize curves cop, but we have no way to rasterize points. If we look at the documentation, the incoming geometry must be polygons. Rasterizing points with any of these does not work, so we need our own solution. That means if we have our crack here and we scatter some points and we want to bring these points into COPS through our camera view, we need to transform them onto that XY plane, and this is what this wrangler right here does. So you can see it flattens them out and positions them correctly in the camera space. We bring out our camera as the reference, and then we use the toNDC function, which transforms the point positions into the device coordinates of the camera, which would look like this. The problem with that is this goes from 0 to 1, and we need to remap it to center it on the x-axis and then center it on the y-axis. There's just some correction here for the resolution. And then we also want to zero it out on the z-axis, and then we've got our points transformed. Yeah, and if you look at the scattered points through the camera view, you can see that the stamped points line up perfectly now. What you can also do is rotate the sprites using the sprite rotate attribute. And you can scale them using the sprite scale attribute. And what I also like to do is threshold them based on the normal of the points. So back-facing points, I usually remove those just so you get a little more clean stamps. Look at the points here. This is basically the camera direction, like this, and all of the points that are facing backwards get removed. The stamp cup is also used in this setup right here. Here I'm calculating the area for each class per piece attribute. Oops. Extracting the centroid, transferring this area attribute, blasting some points away, and transforming them into camera space like we did before. I'm then using this area with the sprite scale attribute to scale bigger sprites up. And I'm also rotating the arrows so that they always face towards the middle. This is done by calculating the direction towards the center, which is just the negative position, normalizing that, and then plugging that into eta and 2, which returns a rotation value. Problem is this is in the range from -pi to pi, so we need to convert that to degrees. And to manually align the sprites, we have the roll function just to rotate them until it lines up, and then they all face the middle. And the arrow is just done using SDF operations, mainly just combining two SDF shapes. And yeah, the important part is that the middle of the sprite is the actual middle of the image so that it lines up. Next up, we'll take a look at this setup and how to bring text into COPS. The problem right now is there's no way to do text purely in cops. You can't read out attributes, you can't really position them where you want. So we have to do all of the text in subs and then bring it in. The good thing is though, we can just use the rasterize geometry cop to do that. Over in subs we're using the same scattered points, and then we're doing some backface culling in world space using the transform from the camera to the points. We are then creating a string attribute based on the X and Y coordinate. This basically trims the values down to 3 characters after the comma. And this creates a new line so that there's a line break here. And yeah, now each point has a character attribute with the position as a string. And then it gets a little complicated. We are outputting the points here and using a for loop to loop over each point. In the font cop, we have 2 spare inputs. One spare input 0 is the points, and then we also have the link to the metadata. And to build the text, we are basically looping over each point, and we look at the detail of the metadata, see which iteration are we in, and then we access the point corresponding to that iteration, and we're reading out the characters. And if we take a look, there's our string. And yeah, that's basically done in the font sub to build the text, and if we do that for each point, we have our text floating in space. And that can just be sent over to cops to get rasterized with the camera. The next step would be compositing the text using a depth pass. I just rendered out the depth pass here from Karma. And when you rasterize the geometry, you can also just add the depth from I. And you can just plug those into a Z composite node. And if the camera didn't change, you will see that some of the text is now behind the model or gets cut off. I feel like this is really nice to integrate the text into the scene a little bit more. And you can also add a defocus node to add some blur, which also ties it together, because now the depth paths get combined and you get the same blur on the model and the text. I mean, that's a little much here, but I think you get the idea. Last but not least, let's look at this bounding box effect. This is also done in subs and then just rasterized using the rasterize curve sub, rasterize curve cop. Yeah, let's take a look here. We have our input geometry and we calculate the connectivity, and we go through each piece and extract the bounding box using the get bounding box function. This outputs the minimum and maximum corners of the bounding box into these vectors right here. We then subtract the max from the min from the max to get the scale of the box. For each piece we extract the centroid and transfer the scale. And the scale attribute works similar to p-scale, but it has 3 dimensions. And we just copy a normal box onto there, and then it transforms it using the scale attribute. And if we take a look here, for each piece, the bounding box basically fits around the extracted piece, and it updates in real time because we're doing it, well, every frame. We then just bring this into cops, rasterize it again through the rasterize curve cop this time. We're outputting the depth again, and then we can just composite it using the Z composite like we did before. These dotted and dashed lines are done with the curve UV. You basically also output intrinsic UVs from the curves, which will look like this. And we can then use these UVs to sample a ramp. This is just a stripe pattern. and we pipe the UVs into a UV sample and the ramp, and then we get like a striped line effect out of that. And I've noticed that sometimes the problem, because some of the lines are shorter than others and then the stripes are uneven. That's why I came up with this effect to normalize the UVs. I'm basically, for each line, I'm measuring the perimeter, which is basically just the length of the primitive of one line. And we output that perimeter attribute as well. And then we just multiply the UVs, the green channel of the UVs, we just multiply that with the perimeter, and that outputs normalized UVs. They're not exactly normalized, but they're a little more even. And if we take a look at that, which is the third input here, you basically get lines with even spacing regardless of how long the line is. Just to give you an example, here the lines going upwards are a little bit longer than these lines, and these lines are even longer because the line is just longer. But if we switch to our normalized UVs, all of them are a little bit more even and all have the same length. Maybe you want that. And to get these dotted lines, I've increased the size here a bit so you can see more easily. This is also done using the UVs. We're outputting our normalized UVs, and then we're basically using a modulo function, which is hidden in this function cop. Set it to modulus to basically divide the UVs into smaller segments. And this is basically a image square. You can sample any image from that, and I'm just sampling a circle, and this gives you this dotted line effect. It's nowhere near perfect, but I mean, I think it's the best we can do right now. Yeah. And if you look at the switch up here on subs level, you can switch that, and then the bounding boxes get calculated once and transformed. Which is also a cool look, in my opinion. I'll do my best to annotate the file, and download link will be in the description. And it's probably easier just to look around and play around with it yourself. And if you like the whole tracking aesthetic and like to track any input video, you can check out my blob tracker HDA, which will be also in the description, which allows you to track any video footage of your choosing right in COPS. Using some of the same techniques we discussed before, but mainly using the custom blob tracking node, which also outputs points and allows you to create all sorts of cool effects. And if you want to get even deeper into the topic and go one step further and get classification boxes with labels, I recommend you to check out Houdini from Ivan Rees, which is basically a YOLO wrapper, which is an image detection model. Also works in COPS. It's really cool. Lots of cool stuff we can do with that. Yeah, that's basically it. Thanks a lot for watching. Hope you learned something useful from this video.